We are now going to look at technologies for using or disposing of treated effluent. I will also briefly talk about surface disposal and storage of sludge and other solid products that cannot be utilized. Biogas is another sanitation product that can be used beneficially. We will shortly see how. Let's start with the utilization of effluent. Remember that effluent is the general term for a liquid that leaves the technology typically after black water or sludge has undergone solid-liquid separation or some other type of treatment. Depending on the level of treatment, the effluent may be completely sanitized or may still require further treatment before it can be used or disposed of. In general, only water that has had secondary treatment, for example in a physical and then a biological treatment step, should be used to limit the risk of crop contamination and health risks to workers. To reduce dependence on fresh water and increase crop yields by supplying increased water and nutrients to plants, properly treated wastewater can be used for irrigation in agriculture. There are two kinds of irrigation technologies. First, drip irrigation, where the water is slowly dripped on or near the root area, as shown in this drawing here. And second, surface irrigation, where water is routed overland in a series of dug channels or furrows, as you can see on this photo. Of course, it is also possible to manually apply water to plants using watering cans. To minimize evaporation and contact with pathogens, however, spray irrigation should be avoided. WHO published a volume of guidelines specifically on wastewater use in agriculture. These should be consulted for detailed information and specific guidance. You can find this document for download on the course webpage. Another way of generating benefits from treated effluent is the use in aquaculture. Aquaculture refers to the controlled cultivation of aquatic plants and animals. Two examples are fish ponds and floating plant ponds. Fish and plants growing in such ponds remove the nutrients from the wastewater and are eventually harvested. Fish are typically used for consumption or as a source of protein for other animals, and plants like duckweed can be used to feed animals, for instance. Plant ponds can even achieve additional reduction of organic matter and suspended solids. It is possible to combine fish and floating plants in one single pond. There are also WHO guidelines on wastewater and excreta use in aquaculture, containing detailed information about health aspects and specific guidance for risk reduction. You can also download them from the course page if you are interested. In case there is no use for the effluent, it can be discharged to a soak pit, also known as a soak-away or leach pit. A soak pit is a covered, porous-walled chamber that allows water to slowly infiltrate into the ground. It can be left empty and lined with a porous material to provide support and prevent collapse, or left unlined and filled with coarse rocks and gravel, as shown on the photo. Primary treatment of the wastewater is required, in both cases, in order to prevent clogging. As the effluent percolates through the filter material and the surrounding soil, small particles are filtered out by the soil matrix, and organics are digested by microorganisms. This relatively simple technology is best suited for soils with good absorptive properties. A leach field or drainage field is also designed to infiltrate pre-settled effluent. It is a network of perforated pipes that are laid in underground gravel-filled trenches to dissipate the effluent, typically from a water-based collection and storage technology like a septic tank. The piping system distributes the effluent into the subsurface soil for absorption and further treatment. The treatment takes place by soil microorganisms. To prevent contamination, a leach field should be located sufficiently away from a drinking water source. This technology is particularly appropriate for rural areas where the risk of oversaturating the soil is low and where there is sufficient space. Like for the soak pit, primary treatment of the effluent is crucial to prevent clogging. Treated effluent or stormwater can also be directly discharged into receiving water bodies, such as rivers or lakes, or into the ground to recharge aquifers. The use of the surface water body, for example as a resource for drinking water, influences the quality and quantity of treated wastewater that can be introduced without negative effects. Parameters such as turbidity, temperature, and nutrients, among others, should be closely monitored when releasing effluent into a natural water body. Groundwater recharge is most appropriate for areas where groundwater resources deplete and in coastal communities where saltwater intrusion from the sea becomes a threat. In the previous module, we already looked at agricultural application of treated feces, compost or sludge. In case there is no demand for or acceptance of the beneficial use of these products, surface disposal of the generated solids may be the only option. Surface disposal refers to the stockpiling of sludge, feces, or other materials that cannot be used elsewhere. Once the material has been taken to such a disposal site, it is not used later. Storage refers to temporary stockpiling. It can be done when a future need is anticipated or when further pathogen reduction and drying is desired before application. Surface disposal is primarily used for sludge, although it is applicable for any type of dry, unusable material. Landfilling sludge, along with municipal solid waste, is not advisable, since it reduces the life of a landfill, which has been specifically designed for the containment of more noxious materials. Surface disposal sites should ideally be located close to where the sludge is treated, to minimize transport distances. Attention must be paid to groundwater contamination and leaching. Sites for temporary storage of a product should be covered to avoid re-wetting by rainwater. Biogas is another, quite different type of product from sanitation systems. It contains energy and can basically be used like any fuel gas. As you can see from those pictures here, biogas can be easily used at household level for cooking and for lighting, but it is even possible to operate refrigerators or vehicles with biogas. Another use of biogas is in engines to generate electricity, like the small one shown here. At household level, cooking is the most suitable use, because the calorific efficiency of 55% is quite high for that application. With only 3%, biogas lamps are far less efficient. We have seen that properly treated effluent can also be beneficially used in agriculture or aquaculture. Its constant availability throughout the year may reduce farmers' dependence on freshwater, and the valuable nutrient contents can help to improve crop yields. If utilization is not possible or desired, ways to safely dispose of the generated effluent or solid materials have to be found. In order not to pollute the environment, it is of particular importance to identify appropriate sites to dispose of those products. Sanitation systems can be designed not only to recover water and nutrients, but also energy. Biogas is a valuable source of renewable energy that can be easily generated and used. The following module is about innovative, emerging technologies and ongoing developments in the sanitation sector.